Okay, here's a review video on one of the worksheets that we did in class. It goes over Unit 3, Lesson 5, and Lesson 6. Um, so in Lesson 5, or this unit, in Unit 3, we talked about a lot about dilations, right? It's one of the transformations that we learned. Um, there's three rigid transformations. There's translations. Here, let me write this down. Translation. Rigid transformations. There's a translation where we're like sliding shapes from one place to another. There's a rotation where we're like rotating things around. And then there's reflection, right? Those are the three rigid transformations. And then there's a non-rigid transformation. That just means that there's no congruence, right? Rigid means it stays exactly the same, which is just dilation. It's not congruent because the shape like either gets bigger or smaller depending on the scale factor. Okay, so we've been practicing dilations a lot. We've practiced dilating a side, dilating a shape. Now we're kind of talking about what kind of properties are added onto those dilations, right? So in lesson 5, we kind of looked at this when we have midpoints of each of the sides. So in each of these triangles, M, N, and P are midpoints of the sides. Name a segment parallel to the one given. Let's look at number 1, right? I'm looking at these points here, N, P, and M. They're all midpoints of their respective side. N is the midpoint of J and K. So I'm going to put these marks here because JN is congruent to NK because it's cut in half, right? This half is equal to the other half. Same thing with KP and PI, because P is the midpoint, those two parts are congruent. And then same thing with JM and MI, those are also congruent, okay? So when we have midpoints and we connect the midpoints with a line, like N and P are connected here, M and P are connected here, and N and M are connected there, they create parallel lines, okay? So we have JK, right? We're asking what line is JK parallel to? When you look at the picture, it should be obvious it's going to be MP. JK is parallel to MP. They go in this like same direction, right? If we extended these lines, and they never meet, they never touch, they never cross. So that's parallel. If I asked you, what is parallel to KI, right? You should think NM. If I ask you what's parallel to NP, right? You should have thought JI. Okay? So parallel. Number 2, I'm gonna trust that you can do number 2 on your own. I'm gonna keep going. Let's look at number 3. Right? Find the missing length indicated. Find the missing length indicated. We're trying to figure out what's the length of RQ. Okay? I'm seeing familiar things here. Right? I'm seeing this mark here that states RN is congruent to let's say RM. And then same thing on the other side. QM is congruent to QL. They both have these 2 marks, right? So that means those parts are congruent. So if those halves are congruent to each other, then that means R and Q are midpoints here. Are midpoints. So what does that do? Right? If R and Q are midpoints, what can we get from that information? That creates this line right here, and I see this smaller triangle. I see this triangle here. I'm going to color it in red. And then I also see a bigger triangle in blue. Right? And because this is double the size, I go from MR to MN, and I'm doubling the size, right? Because I'm adding another length of MR. And then same thing on the other side, MQ is a small triangle, the side from the small triangle, and I'm doubling it when I compare it to ML, the blue triangle. So our scale factor, right, because we have midpoint. That means our scale factor is going to be either 2 or 1/2, depending on which like triangle we're going from. Like if we're going from the bigger triangle to the smaller triangle, scale factor is 1/2. If we're going from the smaller triangle to the bigger one, it's 2. So let me write my equation, right? RQ is corresponding to NL. So I know since if we're going from the bigger triangle NL to the smaller triangle RQ, that means my scale factor is 1/2, right? That means our scale factor is 1/2. Or another way to look at it is RQ, right, times 2. If you multiply 2 to RQ, then you're going to get NL. NL is double the size of RQ. I know NL is 8. That's given to us right here. And if I plug in, if I just kind of drop down the rest of it and I want to solve for RQ, I just divide both sides by 2. And I could get RQ is equal to 4. Okay. Another way to look at this is, okay, if I'm going from the smaller triangle, I'm sorry, the bigger triangle, right? If I'm going from the bigger triangle to the smaller triangle, RQ, or the side of the smaller triangle, that means we're going to multiply NL times our scale factor, 1/2, and you're going to get the length of RQ, because you're going from big to small. The bigger triangle to the smaller triangle is 1/2 of the big one. So it's the same thing. 8 times 1/2, it's going to be 4. So either explanation works. You get the same answer, telling me the same thing. You're telling the same story, okay? So try out number 4. Set up your equation however you want. You can use the left side this way or this way. You should be able to try that out, okay, on your own. All right, what about this one? Number 5 and 6, right? I'm going to do number 5. You try number 6. Same thing here, right? I set up like, whatever I did up here. I'm following the same equation, right? I have the midpoint thing again, right? A is a midpoint, B is a midpoint. I know that because of these marks here. So that means, sorry, I just had a brain fart. AB and UW are corresponding sides of the triangles. I have this little triangle here, and then I have the big triangle on the outside, okay? So how do I set up my equation? I know UW is going to be double the size of AB, right? We learned this equation in lesson 5. We did a whole proof on this where we were saying that, oh, that side is going to be double the side of the bigger triangle. Okay, so we know UW, is 3x minus 10. 3x minus 10, right? We see that right here. And then AB is x, right? Is x. So I'm plugging in x for AB. I'm plugging in 3x minus 10 for UW. Let me color code here so you know exactly what I'm talking about. Boom. Okay? And then let's just solve for x, right? I have an x, I have 3x on the left side, I have 2x on the right side. I don't need both of them. So I'm going to go ahead and just eliminate 1. Okay, I'm going to subtract 3x on both sides. Negative 10. 2x minus 3x is negative 1x. I don't want negative 1 in front of the x. I want to get x by itself, so I need to divide both sides by negative 1. X is equal to 10. Okay? Final answer. So try out number 6 on your own. Like, solve it the same way. Okay, solve it the same way. I'm going to keep going though. For the next one, I'm actually going to do number 8, and you try number 7 because number 8 is actually harder. So now it says find the missing length indicated, right? It doesn't say solve for x. It says find the missing length. So in number 8, I want to find out what DE is. DE is right here. Okay. And I know DE is 2x minus 16. The other side, MK, right, which is corresponding to DE. Again, I can only assume this because of these marks again. I have these marks, that means D and E are midpoints. So I know the relationship of the two triangles. The scale factor is 2 again. So let me set it up. MK is the bigger side, right? So MK equals double the size of the smaller side DE. MK is double the size. I know MK is 2x minus 14. And I know DE is 2x minus 16. Notice how I put parentheses, right? Because I need to multiply that 2 to the entire side of DE. I'm not just multiplying 2 with 2x. I need to multiply to the entire thing. So let's distribute. Let's do that. I don't need to explain distribution property anymore. You should know this by now. 2 times 2x, that's 4x, minus 2 times 16, that's 32. And now it doesn't really matter what you start with. You could do anything, right? I could eliminate 2x. I could eliminate negative 14. I could eliminate 4x. I could eliminate negative 32. I'm just going to start with this, okay? It really doesn't matter as long as you're doing the algebra correctly. I don't have 2x's anymore. I just have 1. Now let's start cleaning up the right side and get x by itself. I need to eliminate this 32, so I'm going to do the opposite. That should get you 18. Negative 14 plus 32 is 18. And then 2x, that's 2 times x, so the inverse operation would be dividing by 2. So we get x equals 9. But a lot of people have been saying, oh, my answer doesn't match your answer key. Plug it back in, right? The question said solve for DE. DE is 2x minus 16. So plug it in, 2 times 9, oops, minus 16. 2 times 9, that's 18. Minus 16. Your final answer is 2. So DE equals 2. Okay, so trial number 7 should be a lot easier. Not a lot easier, but same process as number 8, but easier. Okay. This is where a majority of the questions here on the other part is closer to lesson 6, right? Lesson 6. So maybe by the time you watch this video, we'll have gone over lesson 6. But technically I gave you this worksheet before we even started lesson 6. So there's some new words here. Okay. Similar. Similar in everyday English just means like, oh, it resembles the other thing. Oh, we're similar because we have glasses. We're similar because we're the same ethnicity. We're similar because we're the same height. We're similar because we have the same type of hair. So if you find common factors with the other person or other, right, whatever it is, then you are similar. It's the same thing with shapes in geometry. The shapes are the same. The angles are the same. It's very similar to each other. The only different thing is that one's bigger and one's smaller. Okay, so it's kind of the same thing as dilation, right? We're dilating these different shapes. So we're asked to find a missing length. So I'm going to do number 9. You're going to try number 10. And I'm going to give you this like whole very like complicated, like really detailed step-by-step solution. It doesn't have to be complicated. Oops. But I just really want to make sure that I'm very clear with my steps so that you don't get lost. Okay. So I'm trying to figure out what is the measure, what is JL, right? I don't know what JL is. There's a question mark here. But I'm given these two triangles. So maybe JL, right, corresponds to another one of these sides. Maybe it corresponds to this one or this one. I'm not too sure yet. I could take a guess. You could probably just look at the pictures and guess. But I want to be sure. How do I be sure that they're corresponding? You have to pay attention to the similarity statement. This little squiggly line means that the two triangles are similar, right? When we say congruent, we do the squiggly line and an equal sign. With just a squiggly line means similar, okay? So triangle TUV is similar to triangle LKJ, right? I put numbers over the letters to show what order they're in. So I know JL is number 3 and number 1. JL is 3, 1, right? So that means it's corresponding to 3, 1 on the other triangle, which is TV, right? So I know I have to do something with TV and JL because they're corresponding sides. But I need to find a scale factor first. Clearly this triangle is the smaller one, this triangle is the bigger one. So that's the first step here. We're going to find the scale factor. So step 1, find scale factor and scale factor. And there's this formula that you use every time. There's a bunch of, like, not a bunch of different ways, but you could kind of think of it logically as well, right? Remember, if scale factor is greater than 1, then it's getting bigger. If it's less than 1, then it's getting smaller. So to find a scale factor consistently every time, you want to figure out what is your image and what is your pre-image. So image means like what shape are we ending on? What's the like end product and what are we starting at? Pre-image is where we're starting. So we're trying to solve for the missing side JL, right? So if that's what we're trying to solve for, that should be our image. That's our end product. We're trying to figure out this one, this triangle, JKL is our image. So that means we're starting from the bigger one, right? This is our pre-image. This is our start. So I need to find a ratio of two sides on the image and pre-image and use the ratio of the sides for my scale factor. So I'm looking at the pictures and the only two sides that are left over are 27 and 117, right? If you want to double check if they're corresponding, look at the order of the letters. 27 is KL, KL, that's 1 and 2. And then 117 is UT, which is 1 and 2. So they're good. So let's set it up, right? My scale factor is going to be the image first, which is 27, over the pre-image, which is 117. 27 over 117. You could just leave this as your scale factor, but if this really bugs you, you could simplify, right? I know that both terms are divisible by 9, so I'm going to simplify by dividing the top and the bottom by 9. 27 divided by 3, oops, that is 3. 117 divided by, 27 divided by 9 is 3. 117 divided by 9, that's 13. So the scale factor, you could use either 27 over 117 or you could use 3 and 13. Doesn't matter, okay? I'm going to use 3 and 13. I did the work to simplify. If you use 27 over 17, 117 is the same thing, okay? So we found a scale factor. Now step 2, let's find a missing side. Find missing side. So how are we going to find the missing side JL? Okay, we're going to use TV. We know TV corresponds to JL, right? So we're going from TV, this side, 91. This is a pre-image. And then we're going to multiply by our scale factor to get the image. It's kind of like, remember we did that activity in the book? You don't have to write this down. We had like, oops, what the hell? We had AB, right? And we said, oh, this was 3.5 centimeters. And then it said dilate this line by a scale factor of 3. So all we did was, okay, 3.5, sorry, 3.5 times 3. Oh, that's 10.5, right? So then we just measured from A to where 10.5 is going to be. Let's just say that's 10.5. And now that's our dilated line, right? So it's the same thing here. You're just going to take the original side, the pre-image, which is 91 TV. So I'm going to write that down, TV, times the scale factor. I'm going to use 3 over 13, but you could use 27 over 117. And that should equal our side JL. I already know that TV is 91. So I'm going to plug in 91 times 3 over 13. 91, when you multiply a whole number with a fraction, you should know this by now, you multiply to the top and then divide by the bottom. Okay? So just take it one step at a time. 91 times 3, that's 273. Divided by 13, that is going to be 21. Okay? So the side, JL, is 21. 21, this is going to be 21. 21. It's a bunch of different ways to do this, but if you don't know how to do it like this, finding the scale factor and then finding the missing side by multiplying by the scale factor, then you don't understand what it means to have a dilation. You don't understand what it means to have similar shapes. So you need to get it down like this, okay? So try this out. Try number 10. It's very similar. I'm going to let you try it. Again, once you have your answer, look at the answer key to double check your work. Let's keep going. Whoa. How come? That's weird. How come number 11 doesn't have a similarity statement? Okay, whatever. 11 and 12 is the same thing, right? So go ahead and try it out for 11 and 12. Maybe I'll come back to one of these. I just want to make sure I hit everything else, okay? Because there's a couple more I need to hit. So let's look at this one. The polygons in each pair are similar. Find the scale factor. Find the scale factor, so we know how to do that, of the smaller figure to the larger figure. So that means our smaller figure is our pre-image. We're starting at the smaller one. And then our larger figure is the image. Wait. Yeah. Sorry, I had to think about that. Okay, so, okay, right? I have my triangles lined up already. This is the smaller figure, obviously. I'm just small. And then this is a bigger figure, large. I'm going to take corresponding sides from the smaller figure and the bigger figure to get our scale factor. Okay, scale factor is always equal to the image, one side from the image, over one side from the pre-image, the corresponding parts. So again, smaller is pre-image, and then bigger is image. So I'm going to do 40, right? Because 40 is the side from the image, over, I'm going to do a different color for pre-image. The pre-image should be 8. Okay, because those two sides are on corresponding parts. The polygons are similar. So let's simplify this. 40 divided by 8, you can actually just divide that. Your scale factor is going to be 5. So that means the bigger triangle is 5 times bigger than the smaller triangle, right? You're going from 8. How do you go from 8 to 40? That's times 5. Times 5. Do the same thing for 14, 15, and 16. Okay, they're exactly the same. It shouldn't be any different from what we just did in number 13. Okay, let's look at these. The polygons in each pair are similar. Find the missing length. Okay, so now they want us to find the missing length. Okay, so it's the same thing here. You could solve it, okay, a bunch of different ways, but if you just look at the picture, it's very straightforward. You could solve it using the same method that we did in number 9. It's a lot of steps though, right? But if you just look at the picture, you can kind of tell what the scale factor is going to be, right? So I'm trying to find the side of the bigger shape. So this is our image. This one is our pre-image. We're starting from the smaller triangle. Sorry, not triangle, rectangle. And then we're ending up at the bigger one. So I need to pick out some corresponding sides. Let's look at 4 and let's look at 12. What am I multiplying to get from 4 to 12? 4 times what? Equals 12. Right? And you're multiplying by 3. So our scale factor here is going to be 3. So that means 6 is the corresponding side of the missing side on the bigger triangle. So all you got to do is 6 times 3 is going to get you the missing side, which is 18. Okay. If you want to solve it the same way you did in number 9, okay, let's do it. Scale factor. Our scale factor is going to be the image over the pre-image. So I'm going to do 12 over 4 because 12 is the image, 4 is the pre-image. 12 divided by 4, that's 3. So find the missing side. I need to take this side and multiply by 3 to get this side. So I'm doing 6 times 3 to get 18. That's it. That's how you show your work. I'll even do number 18 for you. Right? I'm going to give you a second to think. Which one's the pre-image? Which one's the image? Good job, right? Smaller shape is the image. Bigger shape is the pre-image. We're trying to figure out what this side is, right? So that's going to be our image. I know these two match, and I know these two match. So let's find the scale factor using the blue sides, 12 and 20. So scale factor. This one's not as obvious, right? How do you go from 20 to 12? You're getting smaller. So our scale factor has to be less than 1. So set it up. Image over pre-image, that's 12 over 20. You could simplify here. I know both terms are divisible by 4. So really your scale factor is 3/5. Right? So 20 times 3 over 5 is going to get you 12. Right? So how do I use that logic, right? 40 times 3 over 5 is going to get you the missing side here. So 40 times 3 over 5, because that's our scale factor. Again, multiplying. Whoa, what's going on? Damn, my screen is frozen. Oh, just kidding. Okay, 40 times 3 over 5, multiply to the top, then divide by the bottom. 40 times 3 is 120. Divided by 5, that is 224. Okay, so our missing side is 24. Okay, you guys got to do the other ones. You guys got to do the other ones. Okay, so how do I do 21, 22, 23, 24? So let me go over 21, and then you try the rest. So same steps here. Solve for x. The polygons in each pair are similar. So I know these two sides are corresponding, and I know these two sides are corresponding. Okay, I want to find a scale factor. So the scale factor here is going to be scale factor. I guess it doesn't matter which one you pick the image and pre-image to be here, right? We're trying to solve for x. Okay, so let's say this one is the image because we want to figure out what x is, and this one is the pre-image. Okay, so we're going from the smaller shape to the bigger shape. So our scale factor is to be greater than 1. Image over pre-image, so our scale factor is 40 over 8. We did this before, that's 5, right? That's 5. 40 divided by 8 is 5. So that means, how do I go from 8 to 40? That's times 5. How do I go from 6 to x plus 18? That is going to be times 5, right? So what are we saying here? We're saying that x plus 18 is 5 times bigger than 6. So x plus 18 is 5 times bigger than 6. So I set up my equation like that. It's going to be equal to 30. I just minus 18 on both sides. X is equal to 12. 12. How can you check your work to see if this is true? If I plug in 12 in the x, 12 plus 18, that's 30. Is 6 times 5 equal to 30? Yup. So, yeah, that's correct. Okay. Or you could, yeah, you could just, actually, yeah, that makes sense, do I want to go back into this one? Do I want to go back and do this one? Nah, I'm tired. I'm going to do these other ones. You guys can figure it out. Right? If you really need help on those, nutrition lunch. Let me do, instead of doing that one, let's do 22. Let's do number 22. Okay, same thing. I see these sides are corresponding, they match up, and I see these sides are corresponding. These sides match up. X is on the bigger shape, so I'm going to say that's my image. And then the other one is my pre-image. I'm starting with that. Let's find a scale factor. How do I go from 25 to 30? What am I multiplying by? Right, so it's going to be another fraction here because it's getting, well, yeah, it doesn't, there's no like whole number you can multiply 25 by to get 30. But we know it's greater than 1 because it's getting bigger. So scale factor is equal to image over pre-image. So 30 over 25. I can simplify this. They're both divisible by 5. So that's 6 over 5. 6 over 5. Not the other one. Scale factor is 6 over 5. So that means when you compare this side and this side, you're doing 40 times 6 over 5 gets you 7x minus 8, right? So 7x minus 8 is equal to 40 times 6, or let's say 6 over 5. Oh, you know what? Whatever. 40 times 6 over 5. Let's simplify the right side. Times, multiply the top, then divide by the bottom. 40 times 6, that's 240. Divided by 5, that is 48. Add 8 on both sides. Boom, boom, boom. It's 56. And then just divide. Right, divide by 7. X equals 8. Good answer. All right. This is 34 minutes of good stuff here. Okay, this video better get at least 100 views. At least 100 views. I don't know. All right, goodbye.